Erica, you're like, no, you're not. What, Jenna? Yeah, you can. Thanks for asking, Jenna. Yeah, you can have one too. Riley, I missed you. All right, get out that worky shooty. Also, we are live. So here's the plan. We are on page not 1, not page 2. Also, I got a new staple. I got a new stapler. It's back there. It's red. I heard that Miss Palmer has the same kind, and so does Miss Landez, which means they have good taste. But we all know I'm the coolest, and that's all that matters. So go to page 3. It's this page. This one. We are so zoomed right now. All right, we did these the other day. Remember, this one was the one where I asked, where are your gods now, right? And then we were okay. Then I said, try your hand at this one. Anybody get this one? I think they did. Anybody at all? Anybody? Anybody at all? Anyone? No one. Not a single person. Well, that's unfortunate. All right, so here's what I think. What do you know about these 3 angles? They should add to 180. They should be supplementary, right? Because they're all sitting on this line. Together by angle addition postulate, they should form this linear pair, right? These two together right there, that's one angle we could say, and then we could say that's the other one, and they're a linear pair. So we know 2x plus 90 plus x equals 180, which means 3x equals 90. Subtract 90 from one side. Put our x's together. Terrible idea in real life, great idea in math. And then we divide by 3 and we find out that x is indeed 30 degrees, which then tells us that this angle right here is going to be 30 degrees. And this angle in a different color, because they are not congruent, will be 60 degrees. Ah, that was a nice 0. I like that 0. All right. So the question is, 2y and z, how do we solve a problem like Maria? Now, you might think, oh, look, 2y and z are a linear pair. They add up to 180, and that's true. Let's write that out. 2y plus z equals 180. Can everybody see what I'm writing? Yes, you can.
What if you break those?
Doesn't matter. I have contacts. I'm invincible now.
Yeah, but you still need glasses.
Your logic is invalid.
But what about when you go back to the eye doctor and they ask?
Look at all of this concern you're showing for me. No one cares. Boring. Can't hear you. Don't care. All right, this thing. How many variables do we have in this equation? 2 variables. We have one equation with 2 variables. Cannot solve, right? We could get z on its own by subtracting 2y, and that would tell us what z is in terms of y, right? It's 180 minus whatever 2y is. But it doesn't give us a number, which is not what we're looking for. No yawning in math class. So, while this is a true statement, it is not a helpful statement. It's like when I insult you guys. It's true, but it's probably not helpful. But I'm all about the truth. Noah, what's your thought?
2y plus 90 equals 180 degrees.
Why is that?
Because they're on the same line.
2y and 90 are on the same line?
Basically.
These two?
Yeah. I mean,
Kind of.
if you're looking at that line.
This is true.
I don't know what I'm saying, but that makes sense in my head.
I would argue that 2y plus 90 plus whatever this is going to be 180 because it's a triangle. And 2y plus 90 isn't always going to equal 180. Or it can't equal 180 because of that, right? So again, to illustrate what I'm saying here, this angle right there, Noah, the orange one, and 90 and 2y, I know have to add up to 180 altogether. So I know for a fact that 2y and 90 aren't going to be adding up to 180. So y has to be less than 45. So we did learn that. No, that's fine, right? 2y has to be, or y has to be less than 45, because if it was 45, we'd get 180 between these two angles, and then we'd have nothing left over for the orange. Anybody? Yeah!
Can you put the x in its same relative position in the corresponding?
Beautiful. All right, so check it out. If I cover this up, don't we have, like, let me cover it up a little bit more. Don't we have two parallel lines being cut by a transversal? And the transversal in this case is this line right here. You dig? You smell what I'm stepping in?
Yeah.
That's the transversal. These are the two parallel lines. That means this angle right here is going to be the same angle here. Right? So that's 30. They're corresponding. So now we know what about angle Z?
It's 150.
How do you know that? So check it out. She noticed, she didn't say it, but she noticed that this angle right here, Z, and that angle 30 are a linear pair. They're sitting on the transversal, aren't they? They're an upside down linear pair, but they're still a linear pair, which means Z plus 30 should equal 180. That's a true statement, which means Z is then 150. Now you might also notice that this angle here and this angle here are congruent. Why are these two angles congruent? They're vertical angles, aren't they? So the angle itself is 30 degrees right here, which means Y is going to be what? 15. So we found out Z is 150. And we found out Y is 15. What you also might notice, we haven't really been allowed to use this yet, but these are alternate interior angles, aren't they? And when the parallels are, or when the lines are parallel, then the alternate interior angles will be congruent. And we can prove that, right? These guys are the same, therefore vertical angles. So look, those guys are the same, right? Always will be. Not bad. Not bad. I think the danger with these diagrams is there's a bunch of lines all over the place. And as far as we're concerned right now, all we know is transversal stuff, right? So trying to just like condense it down to where it's just, hey, two parallels and a transversal lets you see the picture more clearly, right? Same thing over here. We have two parallels and a transversal. So what do I know about the red angle and the orange angle? Just for funsies. What do I know about the red and the orange? They're congruent because they're alternate interior angles, right? And I can prove that because these are corresponding and they're congruent, right? And then these guys are vertical. So it turns out that orange angle isn't a different angle. It's the same. Cool. All right, turn the page. We're yawning in math class, Jenna. It says example, using a third parallel line, and they say it's an auxiliary line. Auxiliary means it's like an aux cable, right? It's extra, it's bonus. What? What is that face for, Peters? Wow. You know who Ellie is?
Yeah.
Okay, you made a face like Ellie. She does that. She sits in Jenna's seat. And she's just like
Really, I love that.
the entire time, and I'm just like, Ellie, are you upset, or can you just not see, or are you confused?
Yeah, she really does really.
No, she does. She's actually really good. Shout out to Ellie. She actually like killed like the last two exams. She's really good at this stuff. No, that's not true. It really isn't. Trust me. I have no problem with calling people dumb. Yeah, she does, just like we all do. But actually, Ellie, shout out to Ellie. Ellie's great. We love Ellie. All right. Here we are. So that's my auxiliary parallel line. I say it's parallel, and so it is. You can do that whenever you want.
Wait,
What?
like on his.
No one cares. Boo. Waste of our time. All right. So figuring out that angle would be impossible without using this parallel line, because what this does is it breaks it down into two parallel lines being cut by a transversal, right? And so now I can figure out what this angle is right here. Again, not x, but the top part of x, right? Do you see it? What? No. All right, so two parallel lines being cut by a transversal. That means this angle here corresponds to what angle? The 50, right? They're both top right corners. Yep. So they're going to be congruent. So this part of x is 50 degrees. Now if I cover up these guys, imagine that line extends further, right? That's our transversal now. Here's our parallel. Here's our parallel. Everybody seen what I'm saying? Okay. We know that this 100 degrees right there, let's do it in light blue. That angle right there is going to correspond to what angle? This one right here, by alternate interior angles theorem. Cool. So if that's 100, what will this other half of x be? And by half, I mean that not literally. The other part of x. What's going to be? 80, right? Because they're a linear pair. Everybody see that? The blue and the green are a linear pair. And so that tells me that x altogether is going to be 80 plus 50 by angle addition postulate, which means x is going to equal 130. If I were to extend these transversals, we'd get something like that. Ignore this transversal for a second. See this line? Well, from here all the way across would be 180, right? From here to here would be 100 because of vertical angles. So let me show you that. From there to there is 100 because of vertical angles. Again, ignore this line right here as best you can. Those are vertical. Same thing with this guy. That one's easier to see, I think. Vertical angles, right? Yes, Lainey? I got 80 because if this is 100, I know that this angle is 100 by alternate interior angles, right? And then this angle, the blue and the green, are a linear pair, so they're supplementary. So 100 plus 80 is going to get you 180, right? Good question. The best questions are ones that don't have complex answers, because those questions can be the most illuminating, right? Not something crazy to see, but once you see it, it's like, oh yeah, okay, good. And if you hadn't asked, you'd have a problem this small holding you back and making it really difficult, right? So thank you for asking. How do you feel? Draw an extra parallel. You can do that whenever you want. Okay, next one. Look, trapezoid, or two triangles. Right. Says find the value of the variables in each figure. Explain your reasoning. We'll explain. All right, so we have two parallel lines. I'm going to extend those out. So I know that I'm looking at a figure here that has two parallel lines and has some transversals. I think we get caught up in the shapes a little too much. There we go. Next thing I'm going to do is I'm going to pick one of the transversals to extend. How about we extend this one? Also, if you want a straight edge, there's straight edges back there. You can use the protractors, right? Picked them up at Farm and Fleet the other day. Protractors. Protractors. Farm and Fleet. Shut up! All right. So, does any other teacher tell you to shut up? That's because they don't actually love you. That's why. All right. So ignore these two lines right here. Okay? Ignore them. We have two parallel lines being cut by a transversal. What? Yes, you may, Chloe, of course. Okay? So we have two parallel lines being cut by a transversal. What does that tell us about this angle? Well, those angles are congruent by vertical, right? These angles right here and right here are corresponding. Again, here's the intersection. It's kind of hard to see it. That's in the bottom right corner of the intersection. Again, ignore this line. Bottom right corner, bottom right corner. There's the other intersection. So they're the same. Easier way maybe is to use alternate interior angles and see that those are the same, right? Alternate interior, right? They're going to be your favorite. So it turns out 3x equals 5x minus 20, which is cool. So let's write that. They're congruent, so they equal each other. A lot of the time the question is going to be, do those two angles equal each other? Are they congruent, right? Or are they supplementary, meaning they add up to 180? And that's the question you're going to be wrestling with, right? Which equation do I set up? Do I add them both up to 180, or do I set them equal to each other? Well, in this case, they're congruent, so I set them equal. We've got one variable for one equation, so that's helpful. I'm going to subtract 3x from this side and add 20 to the other, so 20 is over here now, and positive. And if I subtract over here, I get 2x. How do I separate the 2 from the x? Come on. How do I separate the 2 from the x? Division, right? And division is divorce, so everything gets divided by 2. We get x equals 10. After you find a variable, you should probably go back and plug it back in. So if x is 10, what's the blue angle up here? 30. Now, you could plug it in here and do 50 minus 20 and get 30 again, right? Or you could be like, look, they're congruent. It's 30, right? It's good to check your answer to make sure you didn't goof it up, right? If you don't get 30 for both of these, then you done goofed, right? But it'll be 30. Same thing here. That'll be 30. This will be 30. Yay! Okay, so now what?
Plug the 10 into 3x to get 30, and use that to do stuff with 2y, probably, maybe. I don't know.
Here's the problem. If we knew what this whole measure was, right? If we knew this was like 90 or something, then we could subtract the 30 and say, oh, look, 60 left over, right? But we don't, so that's going to be an issue. I like how you're thinking. That's good.
I just want to say something.
No, it's totally fine. Totally fine. I understand that. I say stuff all the time when things are silent just to say stuff. Like at the end of class, if I ever finish class early, I have no idea what I'm doing with you guys. I just want you to leave. How do I interact with people? I don't know. Just teach. So what do you see?
I see
A triangle. Why do they call it a triangle? It has 3 angles, and 3 angles always sum up to what? 180. So 2y plus 4y plus 30 should be 180. How many variables am I going to have in that equation? Try again. 1. They're both y's. Ha ha ha.
Oh, never mind.
Not anymore. That's the beauty. So we know that all adds up to 180. Okay, cool. So 2y. Let's use green. Plus, no yawning in math class, Riley. Plus 4y plus 30 equals 180. Tiny 180. Can you guys tell this is navy and not black? Can you tell? Isn't that amazing? I feel like as you become an adult, that's like the sign that you've become an adult, if you can tell the difference between black and navy. That's it right there. What am I saying? 6y plus 30 equals 180. We subtract 30, we get 6y equals 150. And then we divide by 6. How many times does 6 go into 150? Don't know, right? How many times does 3 go into 150? How many times does 3 go into 15? 5. So how many times will it go into 150? 50 times. Now 3 is half of 6, right? So if 3 goes in it 50 times, how much does 6 go into it? 25 times. Play with your math. Think differently. Also, think differently. Do we have to subtract 30? Is that the only move we can make here?
No.
What could we have done instead? Divide by 6. Normally we save division for last because it could get us fractions, right? Don't judge her. Okay? So what I could have done is divided everything by 6 and got y plus 5 equals 180 divided by 6. What's 18 divided by 6? 3. So 180 divided by 6 is 30. 10 times that, right? Then subtract 5, we get 25, right? Same dumb crap. PEMDAS is a lie. You just got to know what you're doing. I don't know why they don't say, hey, look, instead of teaching you PEMDAS, which requires you to remember a lot of stuff, right? We don't like membering. When you divide, you just have to divide everything. Okay. I don't know. X is 10, Y is 25. Do we have questions? Yes, you do? Okay, be careful with your head nods. I need clear, distinct yes or no. Thank you. That's all I ask. What you looking at, Shelby? Okay. What you think about? Just math stuff?
Yeah.
Okay, got it. All right, next one. What do you notice, Shelby? No wrong answers here.
There's a quadrilateral.
Wrong. All right, yeah, there's a quadrilateral in the middle. That's true. What do you know about quadrilateral? All right, Shelby, I'm sorry you were interrupted. What else, Shelby? Oh, yeah, I don't have my sunglasses on. You know I have my eyes closed. Shelby,
Yes.
what else do you see?
I don't know.
Neither do I. But it's not because I have my eyes closed. They're totally open.
That's a lot.
All right, who else is raising their hand? Oh, shit. Okay, that's not going to work. All right, my plan is foiled. Jerica, what?
2 sets of parallel lines.
Yep, that's it. Yep. Okay, so they're both sets. They're parallel. All right, so we do one at a time. We know that, look, corresponding angles are congruent, right? So those are corresponding, so they're congruent. Same thing with vertical, right? Which is always true. That's fun. If I cover up these, do I still have two parallels being cut by a transversal? Yes, our transversal is now this line. So that means corresponding angles will once again be congruent. So look, I just figured out that 4z plus 6 does not equal x. So that's fun. That's fun. Now if I cover up these, do I still have two parallels being cut by a transversal? Oh yeah, right? Which means that this right here and this right here are all the same. So what did I just learn? What equals 106?
2y plus 106.
Is 180.
Yes.
Yeah, I mean, we knew that before, but yeah, that's definitely something we know.
Now we can use that to find y.
So that's one way to do it. So Noah's saying I can find y because I know that's a linear pair. All of what I did was completely useless to him. He's like, I don't care, right? I know that's a linear pair no matter what. I can find y. That's great. Are those orange or red rubber bands?
I think they're orange.
Gotcha. Okay. I can tell because she's yawning in math class. What else do we know?
Either.
Yes.
X is congruent to 2y.
X is congruent to 2y. She's absolutely right. Because they're corresponding. What else do we know? Now, what you said is very true, but if I write that out, I'm not going to get either or, right? It's still a very true statement. That is important. What else do we know? I got two variables in one equation here, right? Do you see why that gets us stuck? There's a lot of 106s. All of the orange is 106. So Luke, go a step further. What else do we know? Help him out, Peters.
4z plus 6 equals 106.
Okay, so we can figure out z. And then earlier, Noah mentioned that we can figure out y because 2y plus 106 should equal 180, right? There are many paths that we can take here. The only thing we cannot figure out right now, well, actually, we can figure out everything right now, can't we? So let's do this bottom one just because it's on the bottom. If I subtract 106 and then divide by 2, that seems fair. I could also divide by 2 first, couldn't I? And it would actually work out kind of nicely. What do you want to do, divide by 2 or subtract 106? Be wild! What are you going to do? Divide by 2, okay. So this is going to become y plus 106 divided by 2 is just 53, right? 6 divided by 2 is 3, 100 divided by 2 is 50. So 53. 180 divided by 2 is 90. And then I can subtract 53. Let's count up from 53. How much more do I need to get to 60? If I'm starting at 53, how much more do I need to get to 60? 7. Now I'm at 60. How much more do I need to get to 90? 30. So 37 is what 90 minus 53 is. So instead of subtracting 90 minus 53, I just thought about it differently. I counted up to find the distance between 53 and 90. Remember, subtraction is distance, right? So what I did, you're welcome, is instead of subtracting them and just doing the math, right, what I did is I thought about what it means. Subtraction is distance. How much space is there between those two? Well, I can count from 53 to 90 to figure out how much space there is, right? 10 minus 6 is 4 because there's a distance of 4 between 6 and 10. Starting at 6, 7, 8, 9, 10. Oh, look, they're 4 apart, right? Starting at 53, 7 to get to 60, 30 more to get to 90, 37 total. Boom, there's y. Yes, I can. Thank you for asking, Jenna. How's your morning going? Great, no one cares. All right, 4z plus 6 equals 106. I'm writing it over here so we can do some math. I care, Jenna. I really do. I just wouldn't say it out loud, okay? When you were gone the other day, I was distraught. You got me. All right. Now what? Yeah, we can divide by 4, but it will get us a fraction, right? We're going to get 6 over 4, which is 3 halves. That ain't no thing, but, I know you don't like fractions as much as regular numbers, and who does? Let's be honest. So subtracting 6 will get us 100, which is what we're keeping it. And then we divide by 4 to separate it from the z, right? So regular z is just going to be 25. The only thing funnier than 24. So we found y over here, and I just found z. It's okay. How do we find x? Anybody? Anybody at all? Yeah, Shelby. So we know what y is. It's 37. And that's double of 37. What's double of 37? Let's do it in our head. What's 30 times 2? 60. What's 7 times 2? 14. Add them together. 74. 1 degree short of a perfect day. And we know that x is congruent to that, so x must be 74. Again, you could have plugged it into this equation right here and got x. It's the same crap. It's what we did, right? Yes. Not always. It turns out that x is equal to 74 degrees because it's exactly just regular x, right? Whereas z, I don't know. I guess you could think of it as degrees. You could think of it as not. I mean, I guess it probably is. I don't care, honestly. I'm not that teacher that's going to be like, so what's the answer? And you say 3, and I go, 3 what? 3 elephants? 3 watermelons? No one cares. No one cares. Like, we barely care enough to be here. Let's be honest. Right? Life is hard enough. I like your hair today, Michaela.
Thanks.
You're welcome.
It was with socks.
It was?
Yes.
Interesting. I've never tried that.
Should.
Do you have like a before and after photo of like with it and then like without? I mean, obviously we can see without, but like.
Yes. Well, actually, no.
There was a lot of like. There was. And the way you said it was like you were trying to hide it, but it was like so obvious that there was tension there. That was beautiful. That was good. Like, you can't teach that in acting school. That was great. What do you notice about this diagram?
It has a lot of numbers.
A lot of numbers. What else do you notice? There are 2 transversals, S and R, and we got 2 parallels, right? So if we look at one at a time, we can learn stuff. So 2 parallels being cut by a transversal tells us that the corresponding angles are congruent. So guess what? These guys are congruent, right? And these guys are congruent. Awesome. Now, will 2 be congruent to 4? Well, if we look at just 2 and 4's intersections, right? I'm covering up all the other intersections. Do I have 2 parallel lines being cut by a transversal? No, those aren't parallel, which means cap doesn't apply, right? Corresponding angles postulate. So while 2 and 4 are corresponding, right? They are, right? They same relative position. They're not going to be congruent. Okay, fun. Cover up these two intersections. Do I have two parallel lines being cut by a transversal? I do, which tells me that the corresponding angles are congruent. So those by vertical, those by corresponding. Same thing with these guys. All right, they tell us angle 2 is 92 degrees. A balmy summer day. And they tell us angle 12 is 74, which again is 1 degree short of the perfect day. Find the other angles. Did it. Done. Pretend this was a proof. If they want to know angle 10, what's the quickest way to get angle 10? Explain your reasoning. Peters. Cap, right? We're given that angle 2 is 92, and then by cap, they're congruent. Therefore, angle 10 is 92 as well. Boop. I'm going to zoom out. Anybody need my glasses? I know I said this the other day, but I like your earrings, Chloe. And if I say it multiple times and it like occurs to me and I can't help it, it must mean it's true, right? All right. Angle number 2 is 8. Given that this is 92. We aren't given that 10 is 92. We weren't given that, okay? Could you mark it on your diagram? Sure. I don't like how these things are made, right? Because then you could be like, oh, well, 10 and 8 are, right? No. Given that this is 92, how can we figure out angle 8? Vertical angles, right? So angle 8 is also 92. We did this one by cap. We did this one by VAT. Vertical angles theorem. Angle 9. It's going to take multiple steps, isn't it? How about this? Angle 2 is congruent to angle 10 by what? Cap. And I know 10 and 9 are what? Supplementary by what theorem? Linear pair theorem. We're starting to get it. Therefore, if this is 92, I subtract that from 180, and I get this. What's 180 minus 90? 90. And I subtract 2 more? 88. So 88 is what's left over here, right? I'm going to write that down. Write that down, write that down. So I did that by cap and then vertical angles. Will I ever give you an exam that has you do stuff like this? Good God, no, right? Because like there's a million ways to do it. And maybe you're like, oh, well, I already figured out that 10 is 92, so vertical angles theorem is, or I'm sorry, not vertical angles, linear pair is what we did, right? And you just write LPT. And I'd be like, well, sorry, actually you have to use cap first, right? Like, no. I'll give you what we are used to with proofs, okay? This worksheet's fine. Angle 5. It's a red angle. It's going to take multiple steps to get it done, right? We have a blue angle here. Yes, ma'am?
How did you get 88?
Here's how I got 88. I said these two are congruent, right? So that's 92. Now, angle 10 and angle 9 are a linear pair, so they must add up to 180, right? So if that's 92, 88 left over.
Okay.
Good question. Again, good questions include questions that have simple answers. In fact, very easy solution, but if you hadn't asked that, you would have been like really stuck, right? How about we just don't get stuck? I don't know. Good strategy, right? If you're stuck, ask. Saves time. Angle 5, it's red. We don't have any red angles over here that we know, but we can figure it out. How about this? 74, 74 by cap, right? Linear pair means they're 180. So if I have 74 here, how much is left over? Well, count up. From 74, how much does it take us to get to 180? Or sorry, let's start simpler. 74, how much does it take us to get to 80? 6. Okay, now we're at 80. How much more do we need to get to 180? 100. So 106 left over. So that's 106. And we did that by first, the way I did it is I did cap and then linear pair, right? Can someone do that in reverse, using linear pair first and then cap? Starting here, who can use linear pair first and then use cap to get that this is 106? Peters, try it.
18 is linear pair, and then 8.
Yep, it looks like an 18. It's actually a 13. But yes, 12 and 13, it's cool, are a linear pair. And then if they're a linear pair, they add up to 180, right? So this is 106. And then by cap, 13 and 5 are congruent, right? That's another way to do it. That's why I'm not big on the order when we grade our quizzes, because there's multiple ways to do it, right? Angle 11, well, if we're given this as 74, aren't these guys a linear pair? Done. So that's going to be 106 by LPT. Angle 13 is this angle right here. Well, we just figured that out, right? If we're given that this is 74, well, then by linear pair, it's 106, right? How do you feel? Somewhat okay? All right. Let's go down here. Number 7. Find the value of the variables in each figure. Explain your reasoning. What do you notice about the diagram? When I'm asking you what you notice, really what I'm asking is what are we given, right? What are we given? Anybody? Anybody at all? Anyone? Laney? Yep. Right. And so we have a transversal T, right? Do we need to write the given? No. I'm just pointing out that this is the connection to the proofs we were doing, right? That's why it's important to look at a diagram and say, okay, what do I see? Really what we're asking is, okay, what's given? You should get in the habit of that for proofs, right? Write that down. Before I start going to solve anything, I'm going to start marking up my diagram with what I know. Okay? Now, normally when we do a proof, we write out the reasons for why we know it as well, right? But we're going to skip that for now. Let's look at this angle right here. Don't I know that these two angles are congruent? I always do. Why is that? For the vertical angle theorem, right? So if you wanted to say that these two angles are congruent, right, you'd have to label the angles and figure out what to call them. But like we'd say those two angles are congruent by vertical angle theorem, right? True all the time. What else do I know, given that these two lines are parallel? I know what about the corresponding angles? Corresponding angles will be congruent, right? By cap. So this angle corresponds to this guy, right? They're both the top. So these angles are congruent. Now, what does that tell us about these two expressions? 9x plus 12 should equal 4y minus 10. True statement. But will it be helpful? No, why not? Two different variables, right? We'll get stuck. Right? If we had two equations with two variables, you can solve that. You might have done that in algebra, systems of equations, right? Stuff like that. But we only have one set of equations, right? Just these two added up, right? Or equal each other, I should say. Okay, so that doesn't help. So if we need to find one equation with one variable, there has to be a relationship between these two guys, right? There has to be. Either that or these two. Or I'm sorry, not these two. Nope, because we'd also, again, have x and y, right? Those are a linear pair, so they add up to 180. Still going to get us stuck, right? So there has to be a relationship between these two. So let's figure out what this guy is. What do you notice right away? Well, first of all, vertical angles, right? Second of all, corresponding. They are. The blue and the red are supplementary, aren't they? Another way of thinking of that is, look, those are the same angle. So if that's 3x, then this is 3x, right? And I think it's easier to see now. Those two are a linear pair. So by linear pair theorem, I know that 9x plus 12 plus 3x is going to equal what? 180. I'm going to leave that one for you guys to do. Number 8. What do you notice? Remember, well, whatever. It's fine. Never mind. What do you notice? Anybody at all? Anyone? Anybody at all? Anybody's game. Anybody's game. Anybody's game. Anybody. Not a single person in this room sees anything about this diagram. No wrong answers, except quadrilaterals. We don't want that. Noah!
did the problem last night, so our 4y minus 4 and 3y.
Where are we looking? Are you on number 8?
Yeah.
Where's 4y?
You're 5.
Okay, 5y minus 4. Okay, good. I thought that's what you meant. Okay, so he's saying there's some corresponding angles here. All of those would be corresponding. Now, again, how do we know this? It's because L, M, and N, which I labeled, are all parallel lines, right? We have parallels being cut by a transversal. Again, cover up one at a time so you can see two parallels and a transversal corresponding. Right? Do we still have two parallels being cut by a transversal? Then they're corresponding as well. Then we get vertical angles, right? So we know 5y minus 4 is going to be supplementary to 3y, right? Again, same crap we did before. Is it also true that 3y is going to equal 2x plus 13? Is 3y going to equal that? Is that a true statement? Yeah, it is. They're supplementary. Or I'm sorry, not supplementary. They're corresponding, right? So they are going to be equal. It's just not going to be helpful, right? Because we have two variables in one equation. So you're right. 5y minus 4 is going to be supplementary to 3y, so they're going to add up to 180. Yes, Peters?
2x plus 13 is a linear pair. So 5y.
So another thing that we know is that these two angles are going to be a linear pair. They're going to have to 180. That's a true statement. So this guy plus that guy is going to equal 180. Is it going to be helpful, though? No, because we have two variables in one equation, right? But it's still good to write that because eventually we're going to have to use that, right? We're going to figure out what y is. We're going to go back and plug it in, right? And then we're going to figure out x, right? So 5y minus 4, am I adding it to 3y or is it going to equal 3y? What am I doing? Adding or is it equal to 3y? Adding, right? Because they're supplementary. Again, most of the time you're going to be asking yourself, are those two angles equal or are they supplementary? Right? Sometimes it's neither. But in this case, they are supplementary. We have proven it, right? Corresponding angles, linear pair, therefore they're supplementary. See, proofs aren't so scary. 5y and 3y is 8y minus 4 equals 180. What do you want to do? You want to divide by 8 or add 4? Either way, you don't want to do it. I'm going to divide by 8. You could add 4 and then figure out what 180 divided by 4 is in your own time. That's fine. I'm going to divide by 8. So what I get is y. What's 4 divided by 8? A half. 8 divided by 4 is 2. Reciprocal. What's 180 divided by 8? How many times does 4 go into 80? 20 times. So how many times would 8 go into 80? Well, 10, duh, right? 10. So 10 times to get to 80. How many times does 8 go into 100? Better question. How many times does 4 go into 100? 25. So how many times does 8 go into 100? 12 and a half, right? So 22 and a half is what we get. You guys love decimals, right? And I'm going to add a half to both sides. What do I get? 23. Not really funny. I added a half to both sides, Jenna. 22 and a half plus a half is 23. Okay. Could you have added 4? Sure you could. If you got 184, and you had to ask yourself, well, how many times does 4 go into 84? Well, it goes into it 21 times, so 8's going to go, right? Either way, you're kind of screwed. Yeah.
For number 7, is it 9x plus 12 plus 3x equals 180?
9x plus 12 plus 3x equals 180? Yes, ma'am, because they're supplementary. 8's on your own. I want you to try 9 on your own, 10 on your own, and 11 on your own for homework. Give it a shot. I'll see you tomorrow. All homework will be due at the end of class tomorrow. We are not doing a quiz. It is a short week. Riley, you can rejoice. No quiz. I know you weren't here for the first part of the week. It would be awful to have to do a quiz, right? Although if you're ever absent during the week, you don't have to do the quiz. We talked about that.
Not to do it at all.
Nope. Why would I torture you? Well, I can see where you do. Exactly, right? But then you have to come in and make it up after school or during, or you know, like during homeroom or something, and that's a nightmare, right? And then you're forgetting about it because it's been longer since you've learned it, right? And you missed the days, which means you have to come in and get help, right? So it's really not an advantage to those people. It's really a disadvantage, and I'm just trying to make it more even. As best I can. As best as we can. I love this desk. You know why? It makes great noises.
What if your computer falls back?
Yeah. It's only money. See you later. Did I get contacts? Or didn't I? You'll never know.